Have you ever wondered about the mysteries of the universe that even science can't explain? The cosmos presents us with a tapestry of knowledge, woven with threads of stars, galaxies, and the fundamental forces of nature. Yet within this grand cosmic tapestry there are gaps, threads that seem to disappear into the unknown. This video embarks on a journey to explore 6 intriguing physics phenomena that remain unsolved. Mysteries that continue to challenge our understanding of the universe. We know more about what dark matter isn't than what it is. It doesn't interact with light, making it invisible to our telescopes. It doesn't consist of atoms or the particles that make up familiar matter. Yet we know it exists, its presence betrayed by its gravitational influence. Imagine an invisible dancer swirling around a galaxy, its steps unseen, yet its influence on the galaxy's rotation undeniable. That's dark matter. We observe stars at the edges of galaxies orbiting faster than they should, given the visible matter present. The gravitational pull of something unseen, something massive, is holding these galaxies together. It's like a cosmic glue binding the universe, and it accounts for a whopping 27% of the universe's total mass and energy. How do we study something we can't see? The search for dark matter is a scientific detective story, with scientists devising ingenious methods to detect its subtle influence. From underground laboratories shielded from cosmic rays to powerful particle accelerators, the quest to unravel the mystery of dark matter continues, pushing the boundaries of our understanding of the universe. If dark matter is the cosmic glue, then dark energy is the cosmic accelerator. The universe is not only expanding, its expansion is accelerating. Galaxies are rushing away from each other at an ever-increasing pace, driven by a mysterious force that permeates the cosmos: dark energy. We can picture the universe as a balloon being inflated, with galaxies like dots on its surface moving apart as the balloon expands. But dark energy adds a twist to this analogy. It's as if someone is constantly adding more air to the balloon, causing it to expand faster and faster. This acceleration was a surprising discovery, challenging our understanding of gravity and the fate of the universe. Dark energy is even more enigmatic than dark matter, making up about 68% of the universe's total mass and energy. Its nature remains one of the biggest mysteries in physics. Is it a property of space itself, a cosmological constant, a force that counteracts gravity, or is it something entirely different, a new kind of field or energy that we haven't yet discovered? The answer to this question will shape our understanding of the universe's destiny. Will the universe continue to expand forever, its galaxies becoming increasingly isolated? Or will dark energy eventually weaken, allowing gravity to pull everything back together in a big crunch? For every particle of matter, there exists an antiparticle with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of energy. According to our current understanding of physics, the Big Bang should have created equal amounts of matter and antimatter, leading to a universe filled with nothing but energy. Yet here we are in a universe teeming with matter stars, planets, galaxies, and you and me. If the universe had started with equal amounts of matter and antimatter, they would have annihilated each other, leaving behind a universe devoid of stars and galaxies. So, where did all the antimatter go? The answer lies in a subtle imbalance, a slight asymmetry that favored matter over antimatter in the early universe. This asymmetry, though small, was enough to tip the scales, leaving behind a surplus of matter that would eventually form everything we see in the universe. The search for this asymmetry is a journey into the heart of particle physics, exploring the fundamental building blocks of the universe and the forces that govern their interactions. Scientists are recreating the conditions of the early universe in powerful particle accelerators, smashing protons together at nearly the speed of light, searching for clues to explain this fundamental mystery. Gravity is the architect of the universe, sculpting galaxies, igniting stars, and keeping our feet firmly planted on the ground. It's a force we experience every day, yet its true nature remains one of the most profound mysteries in physics. We know that gravity is a force of attraction between objects with mass. The more massive an object, the stronger its gravitational pull. This force shapes the large-scale structure of the universe, drawing matter together to form galaxies and clusters of galaxies. It's the reason why planets orbit stars and why stars clump together to form galaxies. But gravity is also the most elusive of the fundamental forces. It's much weaker than the other forces of nature, such as electromagnetism and the strong and weak nuclear forces. Imagine trying to pick up a paperclip with a magnet. That's the electromagnetic force at work, easily overcoming gravity. But despite its weakness, gravity dominates on cosmic scales, holding galaxies together and shaping the evolution of the universe. One of the biggest challenges in physics is to reconcile gravity with quantum mechanics, the theory that governs the behavior of particles at the atomic and subatomic level. Quantum mechanics describes the universe as being probabilistic, with particles existing in a superposition of states, while gravity is deterministic, dictating the motion of objects with certainty. Time is a fundamental aspect of our existence, a river that flows relentlessly forward, carrying us from the past to the present and into the future. But what is time, really? Is it a fundamental property of the universe or simply a human construct, a way for us to organize our experiences? We experience time as a linear progression, a series of moments that unfold in a specific order. We remember the past, experience the present, and anticipate the future. But why does time flow in one direction? Why can't we rewind time or jump ahead to the future? The laws of physics don't seem to care about the direction of time. Most physical processes are time symmetric, meaning they can run equally well forward or backward in time. Yet our experience of time is anything but reversible. The answer to this puzzle might lie in the second law of thermodynamics, which states that entropy, a measure of disorder, always increases in a closed system. Imagine a glass of water shattering into pieces on the floor. That's an increase in entropy. It's easy to imagine the process happening in that direction, but it's impossible to imagine the shattered pieces spontaneously reassembling themselves into a glass of water. This asymmetry in entropy might be the reason why we experience time as flowing in one direction. The universe is constantly moving from a state of lower entropy to a state of higher entropy, and time flows along with it. Consciousness is perhaps the most profound mystery of all. It's the ability to experience the world, to feel emotions, to have thoughts, and to be aware of ourselves as individuals. How does consciousness arise from the physical matter of our brains? How can a collection of neurons firing electrical signals give rise to the subjective experience of being alive? We know that consciousness is connected to the brain. Damage to certain parts of the brain can alter or even extinguish consciousness. Yet, the exact nature of this connection remains elusive. Is consciousness a product of complex information processing in the brain, an emergent property that arises from the intricate network of neurons? Or is it something more fundamental, a basic property of the universe, perhaps even a separate entity that interacts with the physical world through the brain? Exploring consciousness through the lens of physics is a daunting task. It requires us to bridge the gap between the objective world of physical laws and the subjective world of personal experience. Some physicists believe that a new physics, one that goes beyond our current understanding of quantum mechanics and general relativity, might be needed to fully explain consciousness. Others suggest that consciousness might be a fundamental property of the universe, just like space and time, and that our brains are receivers of consciousness, not generators of it. The mystery of consciousness is a frontier of scientific inquiry, a challenge that compels us to confront the deepest questions about the nature of reality and our place within it. The universe is a vast and mysterious place, filled with wonders that we are only beginning to understand. The 6 unsolved puzzles we've explored in this video are just a glimpse into the many mysteries that continue to challenge our understanding of the cosmos. From the invisible hand of dark matter to the enigmatic nature of consciousness, these puzzles remind us that there is still so much we don't know.